Hi, I'm Steve Williams with Track. I'm here with John Bushy, Technical Director, American Standard Circuits, and we're continuing the series on our bleeding edge PCB manufacturing topics. Hey John, how you doing?
Good, Steve. How are you?
Good. So I'm old enough and been in this business long enough to remember the old additive process that we used to use for single-sided boards and way back in the day. You want to talk about a newer version of that, right?
That's correct.
Excellent. A-SAP?
Yes, A-SAP. And basically, the only thing it means is a Veritech semi-additive process.
Perfect. Perfect.
Or at least that's how I understand it. And basically what it is it's starting with a bare laminate. And how we get there is by basically taking a pre-existing clad laminate. We etch the copper foil off just like we would with formation of any pattern plated or print and etch job. And we leave the remaining tooth structure behind on that laminate surface, which gives us the surface area required for the necessary adhesion of the subsequent processing chemistry.
So you have to purchase copper clad to remove the copper to get the surface you need.
Correct. And generally, they're using 1 ounce copper. It tends to give the best results from an adhesion standpoint, the increased surface area or depth of roughness seems to benefit this process in some way, shape, or form. So basically, it's etched bare laminate, which is then prepared to receive the liquid metal ink, which is the heart of this process. And so it's a series of baths designed to create energy on the surface of that material, make it wettable, not only wettable by the subsequent process, which really has very little difficulty wetting any surface, but generally just to impart energy to it so that you get the maximum mechanical properties out of the subsequent plated surface. So it goes through lam prep, basically preparing the surface. There's a drying operation, which simply removes any residual moisture. And then there's the key of the operation, which is the liquid metal ink. This is a solvent-based, largely palladium chemistry that is applied to the surface. It's then basically extracted from this chemistry at a controlled rate, which provides a certain thickness of this film, which subsequently is baked or chemically cured onto the surface to achieve the activation of this palladium as well as its adhesion to that surface. And then at the end of all this, there's some sort of metallization that goes over the top of that. It's one of the reasons we call this a semi-additive process. There still will be metallization that needs to be removed from the field areas, or what would be traditionally called the spaces between planes or traces. So that's why it's a semi-additive process. The amount of metallization that you put down is very thin. In this particular instance, we would use electroless copper plating. It's going to be somewhere in the neighborhood of between 30 and 50 microinches of electroless copper. And that basically provides the conductivity for the subsequent electroplating operations. So following this, you go through this sequence of processes and it goes into your standard imaging process, which would be dry film lamination, exposure, and development. We're currently developing the technology and have tested it down to 1 mil lines and 1 mil spaces. This obviously dovetails with some of the other technologies we're working on here at American Standard Circuits, which was the microvia formation, as well as the copper plating filled microvias that were covered in a previous topic. This is all a push for further miniaturization, higher circuit density as we move into more and more HDI technology, and we find that it's finding its way into the high reliability product that we build here on a regular basis. So in a nutshell, it's not completely unlike what we're used to doing, with the following exception, that we go through a specific process in order to metallize the dielectric surface of the laminate. We will largely build up the copper plating only in the areas that are going to remain on the panel, and then we will subsequently what's called a flash etch to remove the field copper to get the individual circuit features that we're looking for in a finished circuit.
I tell you, when I hear you say liquid metal ink, I think of the liquid metal guy in Terminator. That's all I can think about. How long has that been on the market?
It's been on the market several years,
Okay.
And several companies are working with it currently, and we're working very closely with the supplier of Aerotech in developing this process internally. We're working on multiple different laminate systems,
Okay.
so that we can utilize it both in rigid and flexible technology.
Have you noticed with your customers a particular application that this really fits well with?
It really is all driven by lines and spaces.
Okay.
And what we're seeing is a lot of the implantable or even worn or external medical devices, the smaller the better. The smaller the better, so therefore it pushes your lines and spaces down further and further as the geometries get smaller and
Like you
smaller.
said, miniaturization.
Obviously less intrusive.
Okay. Oh, wow. Excellent. Well, John, I appreciate it. This is, again, really interesting, as it always is with you. Appreciate it, Professor, and thanks for your time again.
Thanks, Steve.
Once again, Steve Williams with Track and John Bushy, American Standard Circuits. Thanks for watching.